everyone for being here. Welcome to our latest Whitechapel lecture series. I'm delighted that Sanjooram Paddea has agreed to speak with us, and basically it's about a project which is called TransFIRe. TransFIRe stands for Transforming Foundation Industries, a Research and Innovation Hub. It's a UK research and innovation funded project with a number of research organisations, all UK based, and 70 project partners from across the foundation industries, which many of which are trade associations. So the good news is that it's a live project. The funding is fully secured. It's a lot of money. The challenge has up to £66 million to invest in projects coming via the UK government, to around £83 million is my understanding, all coming from the private sector. So the foundation industries are defined by government as cement, glass, ceramics, paper, metal, and bulk chemicals. I mean, they're all energy intensive areas, and although they can be regarded by some politicians as being boring and old fashioned, actually crucial to all supply chains. And I think this project is a really worthy one. But you may already know, but just in case you don't know, Professor Mark Jolly, a fellow liveryman of ours, he is actually in charge of this whole project via Cranfield University. So credit to him for having put together the necessary documents and arguments in order to make this project go ahead. So at that point, I will be quiet because I've said enough, and I'm going to hand over to Sanju, who will entertain us and inform us in equal measure, I'm sure. And poor old Sanju has not been terribly well, I would say, but he's brave enough to be here tonight. So thank you very much. Go ahead, Sanju. Thank you.
Thank you, Tom. Just waiting to be able to share my screen. Can you allow me to share the screen, please?
Just one moment, please. Coming your way, I think.
Got it.
Good. Thank you.
Should be with you now.
Yeah, we can see that.
Yeah, you can see my screen. Great. Okay, thanks. Yeah, hi. Good evening, everyone. I'm Sanju. I'm the business development and hub manager for the TransFIRe project, as Tom just explained, which stands for Transforming Foundation Industries Research and Innovation Hub. It's a project. I'm actually a materials engineer by background, and I specialized in stress testing of metallic materials. But last year, decided to do something slightly different, so went into this sustainability and net zero project, which started by Professor Mark Jolly, but still manufacturing related. It's obviously a privilege to be speaking to you today, and I would like to take this opportunity to thank Tom for the invitation. I actually met Tom at the UK Metals Council meeting, I think almost a year ago, when the project just started. So we now have some results coming through, so hopefully we can share that with you, and I hope you find my talk insightful. As Tom also mentioned, I unfortunately tested positive for COVID over the weekend, so please excuse my sore throat and occasional coughs. Just one second. So I think Tom also provided a quick introduction, but very quickly, foundation industries, there are, as defined by UKRI, there are 6 of them in the UK. They are the cement, metals, paper, glass, ceramics, and chemicals. They're obviously very important to the UK economy because they contribute actually about 75% of all the materials in the UK economy. And they have a value of about £52 billion per annum. But unfortunately, at the same time, they do create 10% of the CO2 emissions in the UK per annum. So within the project, the TransFIRe project, what we're trying to do is maintaining these competitiveness of these foundation industries in the UK, but at the same time, trying to get rid of that 10% CO2 being generated. The project itself is funded by UKRI. It's for 3 years, and it's £4.7 million over the 3-year period. Plus, we've got some match funding from industry as well to the value of £4.9 million. In total, there are 12 research organizations / universities involved, and we have a number of companies who are supporting us, 80 companies to date, which also includes 14 trade associations and professional engineering institutions, among the likes of the Cast Metal Federation, IOM3, etc. And the project officially started on the 1st of July last year. So we are now well into the first year of the project, and we just started our second year. The project is a small part of a larger, much bigger challenge called the Transforming Foundation Industry Challenge. The whole challenge is actually valued at about £150 million, with £66 million of government money and also some match funding from industry. The vision of the hub, the project itself, is to build a proactive, interdisciplinary research and practice-driven hub that, first of all, optimizing the flow of resources within and between the foundation industries and their supply chains. And the key word here is actually between the foundation industries. So we want to get the metals people talking to the glass people. We want to get the paper people talking to the chemicals people, and so on. Because actually they do share a lot of common processes. So there could be a lot of learning there. We want to improve their competitiveness in the UK and because there's a lot of foreign competition, obviously. Working alongside communities in which they are located. And all this, obviously, to support the UK Net Zero 2050 targets. And then something that I'll come on to a little bit later, which is central to our project, is around ED&I, which is equality, diversity, and inclusion in foundation industries. Overall, TransFIRe will bring together foundation industries and their communities together through interdisciplinary research to support resource productivity, competitiveness, and climate action. As Tom mentioned, and some of you already probably know, Professor Mark Jolly at Cranfield University. I'm also based at Cranfield University, who is the lead in this project, but there are 11 other universities from the likes of Bangor University, who is working on our paper and pulp, British Geological Survey, Cambridge, Cardiff, and so on. And here we've come together in this project to initiate change in these industries by taking a holistic and strategic coordinated approach across the sectors. And you'll see here our consortium is very diverse. At the top, we've got the 12 research universities I've just shown, and then we've got the 6 different sectors, the 6 different foundation industries, the cement, ceramics, chemicals, glass, metals, and paper. And there are 2 numbers there. For example, for cement, there is a 7 and then a 1 in bracket. The 7 is the number of companies in that particular sector, and the 1 is the number of trade association, trade body in that particular sector. So overall, fairly well represented. We could do a little bit better in the paper industry, but that's a little bit due to most of the paper industry in the UK are actually owned by foreign organizations, which makes it a little bit difficult to get them on board as partners. And the 12 universities involved, we've got expertise across various things, starting from energy, life cycle analysis and circular economy, materials, resources, AI and data, management and operations, equipment and instrumentation, and also environment and end users and recycling. In terms of industry partners, as I mentioned, we are 80 plus now, not going through the whole list, but just to show you, we've got from small, medium enterprises to large organizations and trade bodies as well. This number keeps growing on a daily basis. So within the project itself, what we're trying to do, there are 3 different work streams. Work stream 1 at the bottom left there, transferring best practice. Work stream 2 on the bottom right, where there's muck, there's brass. And work stream 3, working with communities. I'll just go one slide on each one of those work stream to explain in a little bit more details. So in our work stream 1, which is led by Professor, actually now, Jonathan Cullen at the University of Cambridge, it's called Gentani. I don't know if you've come across this terminology before, Gentani. It's actually looking at what is the minimum resource that you need to carry out a process. Okay, so let's say you want to make a glass bottle, for example, and if you concentrate on the image on the bottom left there, so you've got your energy inputs and you've got your material inputs. And at the end, you get your useful output, in this case, which is your glass bottle, but also you've got some useful byproducts, some waste products, and some losses. So using this concept of Gentani, what we're trying to do is still get your glass bottle out, but try to optimize the amount of energy and materials that you're putting in, so that you can also at the same time diminish your losses and also minimize the waste products that you're producing. So the aim here is to establish a best practice across the foundation industries by comparing performance of processes across the different sectors. We can then establish practical and theoretical minimum energy and material limits, and we can also benchmark environmental performance. So just to put that a little bit in context, this is for the cement industry in the UK. So on the right-hand side here, you'll see we are mapping the energy and material flow. We're actually doing this for all the foundation industries, but this particular example is for the cement industry. So the Sankey diagram here on the right-hand side, it's a Sankey diagram. It shows the main inputs and outputs of energy and materials. And we can see that we have detailed material inputs and fuel inputs, which are declared on an energy and mass basis. But this approach is mainly to allow us to have a mass and energy balance, energy flow balance. So we describe the main products and also the source of the emissions. So from this Sankey diagram, we can quickly get the main metrics, such as on the left table, you'll see energy intensity and CO2 emissions per kilogram of product, which is an easy method then to compare key performance metrics. And here you'll see we've compared the UK with the global average. And we see that in the UK, we actually consume 15% more energy, but have similar levels of CO2 emissions. So this now tells us, okay, the energy consumption, obviously the efficiency is something we need to look at a little bit more closer in our cement industries in the UK. And now you can take that a step further and you can compare company A with company B and say, why is company A performing better than company B, etc. So we're doing something similar for the metals industry. It's not finalized yet, but work in progress. And then we can take that into a little bit more of a detailed approach where we look at the processes, because a lot of these foundation industries, as I mentioned before, they do share a lot of common processes. One of the most logical one is a lot of them share, heating or grinding or comminution processes. So in this approach, what we can do is we can look at the process in a little bit more detailed approach, so that we can then find similarities between the sectors and the potential for knowledge transfer, again, through best practice. Why is the furnace in a metal production company performing better than a furnace in a ceramics industry? I know there are differences in temperatures and so on, but there could be learnings there, And also going back to this slide here, this is also then provide a business opportunity for companies who are thinking or considering to change the furnaces to electric arc furnaces or considering fuel switching as well. There would be a more solid business case to take such decisions. In workstream 2, which is also called where there's muck, there's brass. Some like to call it where there's muck, there's gold. It's all to do with waste streams, with waste. What we're trying to do, first of all, we want to identify all the waste stream that's coming out from all these foundation industries, okay? So again, all the foundation industry, we're not just looking at metals, not just cement. We're looking at all 6 of them. We want to get all that data into an open access online mineral waste inventory. We are looking at developing new and novel materials that would enable lower energy and CO2 emissions, and also looking at developing entirely new processes that would reduce CO2 and energy consumption. And just to give you an example of the work we've done within this work stream, is we had our first workshop called Industrial Symbiosis, where we got all our 80 partners together in the same room, and they had to come to the workshop a little bit prepared with a list of resources that they have that normally goes to landfill, which on the top left here is called company have, is what you have. And a lot of the foundries in this case came up to us saying, you know, they've got a lot of casting sand, which we have a case study as well on this, and I'll talk about this a little bit more details later. And then the companies also come to the workshop with a list of what they could potentially make use of, which is their wants there. So in total, this was our first workshop. We had a total of 105 company resources, what people have, and 67 resources that people could make use of. And it's useful to note that the haves is not just material input, okay? It can also be expertise. So for example, there you'll see anonymous number 10, data processing capabilities, for example. So all that information is then fed into our software, which is provided by International Synergies, and the software is called Synergy. And at the end, what you get is then some matches. So at the workshop, what we found, 45 companies attended, and we looked at 172 resources in total. And in total, we generated 83 ideas. So what does this actually mean? Ideas here is potential synergy. So that's basically 83 potential waste stream that's been going to landfill that is now can be used by somebody else. Somebody else said, I could potentially make use of this. Let's talk a little bit further. So now we're looking at holding a second and a third workshop, which will be a little bit more regional. The second one will probably be in Wales. And finally, in workstream 3, it's to do with working with communities. In this one, we're looking at business practices, working with communities and companies, new business opportunities, and impact assessment. For example, I mentioned a couple of times already that a lot of these businesses, they emit a lot of waste heat. Something that we're looking at in this particular work stream is, can we potentially make use of that waste heat for, you know, something like market gardening or low-grade district heating, for example. And also you'll see on the bottom right there, some mapping exercise that we've done where we're looking at the manufacturing sites of the companies involved in our projects, where the waste heat are located, where the CO2 is located, and so on. And just to give you an example of a case study that we are working on in this particular work stream is with Alvan's British Aluminium, which is located in Lochaber region in Scotland near Fort William. And it's actually the only remaining aluminium smelter in the UK. And it produces approximately 45 kilotons of aluminium per annum. And I think this figure is set to almost double because they're looking at the planning and expansion, recycling facility, and aluminium billet production. They use mostly decarbonized electricity supplied by hydroelectric power station on nearby Ben Nevis, fed by Loch Lagan Dam and the drainage system. And in this particular case study, what we're looking at is investigating heat capture options for reuse in local community. So can we use the heat coming out of this smelter for district heating networks, vertical and greenhouse horticultural projects? And if obviously this is successful, then it's something we can very quickly learn from and do similar things across the UK. And I mentioned the ED&I, Equality, Diversity and Inclusion. This bit is being led by Professor Sue Black at Durham. And in this bit, it's not a work stream as such, but it's throughout the project where we're looking at reviewing the current best practice in foundation industries around ED&I. We're looking at designing and implementing an ED&I strategy. We're also looking at skills in foundation industries. Young people are not interested anymore in careers in the foundation industries. They think of it as a dirty job, you know. How can we change that? How can we attract these young people into STEM careers? And also changing public perception of the suitability of a career in the foundation industries for women and also BAME and minority groups. And just an excerpt here from the UKRI TFI challenge. This sustainable future can only be achieved in a sector which attracts, retains, supports, and develops the best talent, regardless of background or protected characteristic. So some of the work we've done, and actually this is available on our website, we've now prepared quite a detailed ED&I strategy, and it's been circulated to all our stakeholders for feedback, including Innovate UK, which is a funding body. And this document summarizes the ED&I challenges that is faced by the foundation industries, and it sets out a vision for TransFIRE, the project's role to address. How are we going to address these challenges, our guiding principles, and how we will govern the ED&I program. It has 5 strategic sections, starting by listening, looking to the future, engaging industry leadership, establishing goals, measures, and targets, and also setting foundations for industry culture that is attractive and inclusive of diverse talent. It's free to download from our website if you wanted to find out more about this. We've also, within the ED&I team, we've also created what we are calling a landscape map, because there are similar initiatives elsewhere. IOM3, for example, had an ED&I group, which is now merged, excuse me, merged together with a project, with our project's ED&I activities. But there's also others, you know. So we don't want to duplicate efforts. We want to work with existing initiatives and bring change to the foundation industries. We've also got a partner survey in progress, and we've got an ED&I working group that meets every month or so and discuss the challenges and the progress that we are making. And we're also conducting a number of site visits. And just to finish off, just a couple of slides on some more case studies. Case studies are basically small projects. Just one slide on some of the case studies that we're doing, just to give you a flavor of the different projects that we are working on. The first obvious one, probably that we might be a little bit more interested, is around spent Foundry sand case study. So this one has been put together with the Cast Metal Federation, with the Foundry sector, major CO2 generator, 817,500 tons in 2017. And here we're looking at the waste Foundry sand, which is approximately 120 to 200,000 tons per annum in the UK. The majority of which, please correct me if I'm wrong, is actually landfilled. This Foundry sand, there's a geographic spread because of the Foundry CO2 generated if you wanted to transport the waste sand to landfill. So in this particular case study, what we're trying to do is identify and test the full spent Foundry sand across the foundation industries. The aim is obviously to save energy and CO2 associated with processes and raw materials, divert waste from landfill, and provide economic benefits to foundries, and obviously generating societal benefits as well. So this project has recently started. Some of the work we've done, there's a foundry, William Lee, who's kindly provided some samples, which we've analyzed, looking at the compositional variation of the different samples. And also we've done some preliminary mapping exercise of the UK foundry sites, which is I think about 200 to 300 of them in the UK, and identify some clusters. If eventually we wanted to put a hub where all the sand could go to a hub, where would we best situate this hub? So this mapping exercise would feed into that. Excuse me. Something that doesn't shout foundation industries is related to offshore wind. UK offshore wind capacity is set to increase. If you here on the graph here is set to increase, and we are looking at 40 gigawatts in 2030, and that's set to double to 80 gigawatts in 2050. But at the same time, this places demand on a number of materials, but also at the same time, there is a lot of turbines that are already in use that will reach end of use in the next 10 years. And as you can see from the bottom right picture here, this is going to increase in the next 10 years, but also it will grow steadily to 2050 and beyond. So can we develop novel business opportunities for foundation industries to close the loop in wind turbine end of use management? Just to show you very quickly, the wind turbine has a lot of materials involved there: steel, copper, aluminium, fiberglass, and the blade itself. Again, you've got fiberglass, epoxy resin. So when it's come to end of use, what do you do with all that? How do you separate all this material and put it to better use? Some of them just say, you know, let's just crush it and put it in tarmac or something like that. But we can't just keep going like this. We do need to find a better way of either designing these products and also how we are going to recycle them when they come to the end of use. A couple of projects related to our chemicals team, what chemists do best, which is basically making new things. So here is a small project where they are using waste PET to produce an alkyd. There's 130 tons of PTE contaminated. And actually, this is a zero value waste stream from the plastic recycling industry. But waste PET, we can actually depolymerize it into an alkyd polymer, and as you can see here, and can serve many use. And we have actually done a paint as well. Another example where we are using PET and combining it with powder coating fines from another TransFIRe partner, AkzoNobel, which also, you know, make paint. So this is actually currently being sent to landfill or energy recovery. But we have another project partner called Texan that makes shoes and other leather products that require composite materials for footwear. So we're looking at a small project, again, combining the powder coatings and the waste PET into composite material that can be used inside shoes. Something similar for composite ceiling tiles. And finally, just one more that sort of bring it all together really is a little bit of an extreme one, but this is the waste PET that we've then converted into an alkyd. Then we're using waste bypass dust from the cement industry, from Hanson, waste brucite from the ceramics industry, Luxfer, waste foundry sand from Durham Foundry, glass flake from NSG Pilkington. Combine all this together, what we can actually make is anti-slip filled coatings for floors or reinforced composites. It's just to give you an idea of, you know, what is possible out there with all the waste stream that's currently going to landfill. They might seem small to you, but we're talking a lot of tons here. And finally, just to summarize the project, this is the overall journey of the project. On the left there, we've got the linear wasteful system where we are today. We've got the materials, the energy inputs into the factories or foundation industries. We've got the CO2 emissions, and we've got the products and the waste stream. Within TransFIRe, what we're trying to do, first of all, you'll see the thickness of the arrows for materials energy have actually gone down. This is from our workstream one, if you remember the Gentani approach, where we're optimizing the amount of materials and energy inputs. And also, we're converting some of that waste into useful byproducts into other foundation industries. You've seen from our industrial symbiosis workshop how we've diverted potentially 83 waste stream going to landfill into potentially other uses. And at the same time, we're also trying to get rid of that CO2 altogether. But as a project stands for transforming foundation industry, I think a totally transformed industry, not achievable within the project itself, would look more on the right-hand side here, where the thickness of the materials and energy arrows have gone down even further. And again, we continue to convert the waste into useful byproducts, but at the same time, we're also looking at reducing the amount of products that is into circulation. So a lot more emphasis on reuse, remanufacture, repair, and less emphasis on just making more and more. We do need to reduce our resource use. With this, I would like to thank you for your attention, and if you have any questions.
Yeah, well, first of all, I'd just like to say thank you very much, Sanju. I found that very interesting, and I'm, like you say, I'm very interested in other people's questions and comments, please. Go ahead. David?
Thank you, Chairman. Sanju, fascinating talk and very clear. The question I have is, we're all talking about a target of 2030 for certain reductions. What's your best hope, do you think, from your perspective on this area that you could achieve towards contributing that target?
I think 2030 is not very, very far. And well, we're mostly talking 2050, net zero by 2050, but there's also, I think, certain amount of reduction by 2030. And as I say, not very far. And I really don't think we're going to make it. There's a lot of, well, I'm not saying we won't make it, but there's a lot of projects, a lot of initiatives. You know, people are looking at alternative fuels. People are looking at, you know, alternative raw materials, reducing temperature and so on. I think it will be more a combination of all these factors that's going to bring about some change, but not necessarily by 2030. People talking about, you know, using of hydrogen, but I don't think we are there yet. We're still many, many years away.
Yeah.
John, the master?
You're on mute.
I think you're still muted, John, I'm afraid.
Too much technical assistance needed. Sanjay, thank you very much indeed. Very interesting indeed. Obviously, I've known Mark since he was a student, so I go back a rather long way. I can tell you some stories about him. But two things. One is, goes really back to David's point, is how will you actually, well, three things. How will you actually judge success in this project? Because it's only 3 years long. And it's right. You know, it's a dip in the ocean, isn't it? The second one is, of course, if one could educate designers to use less materials or use them more efficiently, that's another way of reducing the impact. And sorry, but I'm going to get all my questions in because I can see others are lining up. The other project I've been involved in the past 5 years ago was the materials database that NIST were producing, which had a whole load of thermophysical data. I wondered if you're integrated into that at all.
Yeah, okay. So yeah, your first question was measuring impact basically from the project. It's only a 3-year long project and difficult to see the impacts coming in. But what we are certainly seeing within the project is we are identifying a lot of areas where we could improve. For example, for energy efficiency, I showed you the example, for example, where we've identified that the UK is consuming 15% more energy, for example. So now there's more work required now to look a little bit more deeper into this and see where we can claw back that 15% or do even better. But having said that, so we are going to continue measuring the impact of the project beyond the lifetime of the project. So we're looking at actually a 5-10 year horizon. So we'll be looking at how much waste we've diverted from landfill, how much CO2 we've saved, and how much less energy we've consumed. And what was your second question?
Second question was about more education about design, to use materials more efficiently in design.
Yes, that's a problem we are facing, because if you remember on my last slide where I showed you where we are today, what we're trying to do within TransFIRe and what a transformed foundation industry would look like. You know, the industry, they want to be in the middle. They want to keep making more and more products, but they want to use less materials and less energy so that they can save money. but we need to reduce resource use. And actually the numbers that have been quoted is 50%. Yeah. So we need to reduce resource use by 50% to be sustainable. How do we do that? It starts with, I think, the people, first of all. So if we can change the way we buy things, the way we value products, not just changing things, we look at repairing things more or reusing things, not buying unnecessary stuff. It starts there. And then industry, from making things that would be more durable, easier to repair, rather than convincing them to just buy a new one when it's broken. I think that's the way to go. And finally, I think you mentioned something else about other project.
Yeah, about 5 years ago, I started something called the Research Data Alliance, which is huge now. But there was an enormous materials database, everything from properties right through to thermophysical properties, which I'm sure could be integrated into your whatever the diagram was called, beginning with G.
The Sankey diagram. Yes. Yeah, indeed, we are making reference to those, and yeah.
Okay, I think other people would have a stab now.
Next, who would like to? Philip, yeah, please go ahead. I think you're still muted, Philip, I'm afraid.
Yes, I am indeed. I was just going for the button.
Good man.
Sanju, an amazing talk. Thank you very much.
Thank you.
And I'm amazed and very pleased at the progress you've made in such a short space of time. I mean, truly remarkable. I mean, to have started and you're able to deliver the get-togethers, etc. But on a lighter note and a little bit of negative, many decades ago, you think I'm only 32, but I'm a bit older than that. I was doing a management course in Sheffield. A part of that course included accountancy, which I think took all of half a day, which surprised me at the time. And the accountant, who was a chartered accountant, gave an account of a company, let's call it the primary producer, with a nasty waste product, very nasty. Cost a fortune to get rid of.
Yes.
Somebody approached the company, let's call that the secondary one, and they said, we can use that. So they agreed that they would take it for free. And there was a pipe, I remember this pipe, and a U shape went over a wall to the new factory next door.
Okay.
And it ran fine until we get to the corporate bit. Years later, decades later, and somebody in the primary producer decided that it was not fair that they were getting this product for free. Yes, you're smiling. You're there, aren't you?
Yes.
And they tried to charge it. The secondary refused, couldn't, and both failed. So I it's lighthearted, but it just brought it all back to me from about 50, 60 years ago now. And so maybe just a note of caution that when you're putting these things together, that there has to be a long-term benefit.
I think that is a risk and a challenge that we do need to take into account. Yes.
Yeah. Okay. Thank you, Sanjay. And tremendous progress. Well done.
Thank you. Thank you.
Any more questions, comments? Alan? Yeah.
Sanju, like others, thank you so much. I not only found it fascinating, I also found it very encouraging. I felt it was an optimistic talk. The careful and efficient use of resources is an international issue. It's not just a UK issue, clearly. We're talking about the planet. We're not talking about the UK.
Yes.
Are you aware of projects of a similar style to the one that you're running in other industrialized nations, be it Europe, USA, wherever? Are you aware of such similar projects? And if such similar projects do exist, is there cooperation, or is there a proposal of cooperation internationally on this matter?
Yeah, very good question indeed, Matthias. And so within the project, we have an international independent advisory board, which we had to set up, which obviously, as its name suggests, comprises of international members, mostly from academia. And at our first meeting, which happened 6-7 months ago, we asked them the very same question. Are you aware of any such initiatives in your countries? You know, it was like US, Turkey, and Australia, and so on. And all of them said no. And actually, they couldn't think of why. And why they're not doing anything like this that, you know, that is required. So to answer your question very briefly, no, there is no such projects. But they have certainly come back to us, said, you know, we should definitely be working together. And we are trying to find ways to work together. And we're talking big countries, we're talking the US that have nothing of this sort of project. But on the other hand, there are universities, I think, in Sweden and mostly Nordic countries that have done parts of it. So a little bit more experience than us, and that will be helping us as well along the way.
Thank you. So we're ever so slightly ahead of the curve here.
Yes, I would like to think so.
Excellent. Excellent. Thank you again.
Thank you.
Anyone else like to come in? Because if not, I was going to comment myself on two things, really. First of all, the United Kingdom is characterized by having very mature industries in general and international ownership, all of which is both helpful and unhelpful in equal measure. What I do think is that because we have so many of these different streams of waste and products and what else, we're uniquely able, with a bit of applied brain power, which I'm sure our academic colleagues are, you know, working on, as we've just heard, to try and put together. And I think if this project does nothing else but introduce companies to each other and begin to so they properly understand what is achievable when we just talk to each other properly, that would be a fantastic outcome. And I think that's probably the biggest game we get, because you're not going to solve this in 10 minutes. And also, sadly, we have still a case that in sort of relatively new economies in India and China, they are completely focused on just churning out whatever it is they can do for profit, and, you know, still don't care hugely about the consequences of some of their actions. So we can be the conscience of the world at the same time as deriving economic benefit from it if we're clever enough to link ourselves up. So that would be my comment. And I think it is great what you're doing, and, you know, I think it's also couldn't be more poignant to where we need to get. So that was one comment. The second comment was about Foundry sand, because people specifically ask about that. And I would say, on behalf of the industry, that many of the biggest foundries do use the DESA process, which is a green sand, which is bonded with clays and so on, and moisture, so that it doesn't have a complicated chemistry and can be recycled on almost a continuous basis. And some of the biggest producers in the UK use that system very, very effectively and minimize the waste to landfill. Similarly, even those of us, including ourselves, they use chemically bonded sands because we need to for the tech that we need to make the castings right. We do recycle those sands on a quite comprehensive basis. So something like 85 to 90% is recycled viably. But of course, we always get the fines, which is impossible to use in our industry. But of course, they go out to other things. So we're not a complete disgrace. But if we really did hook up with with those fines and get them properly, which is happening now, you know, into road making stuff, I think that can be hugely valuable. Yeah. Kim, I think I saw your hand go up, please. Yeah.
Yes, I've just wondered. You know, the consumer is becoming more and more aware and has choices now. Is anyone working towards like a common equivalent of a kite mark or something with grades where people can make an informed decision about what they buy, given, you know, how efficiently it's been produced in terms of waste and things?
Not that I'm aware of, but I think it has.
Perhaps I can just butt in there, Sanju. I know the OEMs, Kim, these are the big vehicle manufacturers, are getting increasingly excited about causing their suppliers to demonstrate their greenness, in inverted commas. And that is absolutely happening now, and tightening in on some of those things. Also, just for an example, JLR with their Range Rovers, which are largely composed of aluminium, they do promote quite often the fact that you buy a brand new Range Rover today and 70% of its content in aluminium is recycled. And that's as we stand here now. So you know, once again, we're not a complete disaster, but these things can be tuned up to a much higher degree.
Yeah, I think it would be quite useful if there was a bit like we used to have a, you know, a Buy British stamp or something like that, where there was a common, understandable thread where people have a choice and they can see, you know, what's being done. Because I do think everyone has become much more aware about everything, particularly now with what's going on, you know, obviously in Ukraine, where households, you know, are thinking much more about conserving energy than ever they've had before, because, you know, it hits their pockets, not for the right reasons, but, you know, there is a much more awareness now about energy.
Yes.
And we shouldn't lose the moment. You know, if we can do something to, you know, households are all much more aware, everyone's much more aware, children are more aware, and it's their future. Yeah, very, very good point. And I think you're quite right. It's the young people which often drive this, which is great, you know, that we can respond to that, hopefully. No. Any more questions or comments? John, would you like to come in, please? Yeah.
Well, just a general, can you hear me okay? Just a general observation. I've just returned from CERN in Geneva, where the cost of electricity is going to have them shut down the Large Hadron Collider for several months next year. And it does strike me there's a commonality between very large users of energy in these companies and big research organizations. I can think of ITER as another one, whereby some common ground could be tackled, because it's going to kill everybody. It's not just the home market, but frankly, you know, if the energy costs go up by 3 times, which is quite likely, this is common ground for everybody to get together, isn't it? Not just in the materials sector.
Yeah, I agree.
Yeah, absolutely. Yeah, it's well, it's a challenge for the whole world, isn't it? Really, because we have to mend our ways in order to make.
So there's a political component to this as well. That's really what I'm trying to say. I think a lot of times, technically, we forget that we have to get engaged with small p politics, and that's what I used to do quite a lot of. You've got to get in there and get the conscious. Goes back to Kim's point. If the share price starts getting affected by the fact that people are not doing this efficiently, then surely that is a way of getting people to wake up. I don't know what Kim's view would be on that.
Well, you know, it is interesting. You know, as I say, people have become much more aware in the last 5 years, and when I meet companies, top of their agenda is to talk about ESG and all of those things. But I think what's really compounded it is obviously that, you know, where we are in the world with, you know, recession looming, all these energy issues, the average household that would never have even considered some of the things we've been talking about are now quite well educated on the subject. And I think they have a choice. I mean, I get a sense people would like to know how their things are made, where they're made, whether they're made efficiently. You know, people are fed up with Chinese imports coming into the country. They would pay, I'm sure, a little bit more to know that they're buying a sustainable, well-made product. And I'm just not sure that there's any way of a consumer understanding how something's made and having an informed decision about, you know, what they're buying.
Yeah.
And if we could try and put some kind of resource into that, we might find that, you know, British manufacturing comes back again because people start buying British.
That's what we're trying to do.
Yeah, and I think the UK Metals Council, which Sanju is familiar with, are always blowing the trumpet about recycling was invented by us hundreds of years ago. You know, we're not new to this party. Please look at what we've been doing for a long time.
Can I just say one thing, which I've just got to know Sue Black recently in the last few months. She's a remarkable person, actually, Tom, and I do suggest we might approach her to give us a talk.
Okay.
You saw from the colour of her hair, she's not terribly conventional.
That's all right. That matches Professor Mary Ryan. She has a similar taste in hair colours.
Yeah, Sanjay might be able to remind me, but she has a very odd professorship, doesn't it? She is.
Yes.
It's. I've forgotten what it is, but it's incredibly interesting title.
Yeah. Well, she's a professor in computer science.
Yeah, but more than that,
Yes.
She says, I'll have to look it up for you, Tom, but it wakes you up a bit.
Yeah. But she's obviously, well, yeah, she's a fabulous person. She's been honored by the Queen, and she's written the book on saving Bletchley Park and so on. So,
wow. Okay. Right. Any more questions, comments at this stage? Because otherwise, I was going to begin to wrap up by saying thank you very much for everyone who's been here this evening and contributed. I think it is a stimulating subject, as it should be, because it's so crucial to not only manufacturing industry in general, but humanity's ability to survive and manage its way through these major challenges. Because the one thing we've been clever at doing is breeding and breeding. So we've got billions of us, more than ever, actually, got to find some of these solutions if we're all going to succeed. So good to give a thought to it, and good to share with everyone. And last, a very big thank you to Sanju, who kindly put that together for us and has so eloquently explained where we're at, notwithstanding his being marred by not perfect health at the moment. So we're all very appreciative, Sanju.
no,
And I really think it was very, very good indeed. Thank you.
No, thank you.
Right.
Thank you for the invitation. Yeah, it's a privilege. Thanks.
Yes. So without more ado, I wish you all a very happy evening, and we look forward to the next Whitechapel lecture when we get organised. So thank you, Sanju, and give our regards to Mark when you see him. Yeah.
Thank you, everyone. Goodbye.
Bye-bye.
Thank you.
Bye-bye.
Bye-bye.
And thank you, Tom.
No, absolute pleasure. Thank you. Yeah.